Thank you for giving me the opportunity to present today. Females have historically been underrepresented in HIV cure research, particularly in reservoir evolutionary dynamics studies, though this is now changing. So far, the majority of reservoir dynamics studies have focused on females with HIV subtype C, and those with HIV subtype B remain underrepresented. The Women's Interagency HIV Study, or the WIS cohort, can help bridge this knowledge gap, as it features participants for whom longitudinal pre-CART plasma samples dating back to transmission, along with PBMC samples following CART initiation, are available. This gives us the opportunity to study HIV evolution and reservoir dynamics in females. In this study, we reconstruct within-host HIV evolutionary histories in 3 seroconverters from the WIS cohort to infer proviral ages and temporal stability during CART, and compare ages of rebound viruses to the overall proviral pool. Characterization of HIV proviruses sampled during long-term CART can provide insights into reservoir stability, genetic diversity, and dynamics, which can in turn help inform HIV cure strategies. On this figure for each participant, the cohort entry is shown with the right arrow, estimated date of infection as inverted triangle, plasma HIV RNA sampling in circles, PBMC-based proviral sampling in red diamonds, and suppression on CART in gray, with time in years since initiation of CART on x-axis. All participants initiated CART in chronic infection. Please note that pre-CART longitudinal single genome amplified plasma HIV RNA envelope GP120 sequences for these participants were previously published by Dapp et al. In the present study, we use single genome amplification to further characterize proviral DNA sampled on CART for these 3 participants at the time points shown in red diamonds. Specifically, we sampled proviruses 4 times over 5 years for participant 1, 3 times over 4 years for participant 2, and once for participant 3. Also, participant 1 had a period of plasma viremia after their initial regimen was interrupted. During this time, the participant had 3 plasma samples taken, shown as colored open circles. We amplified plasma HIV RNA from these time points with the expectation that these viruses would represent replication-competent HIV emerging from the reservoir after treatment interruption. In the next few slides, I will show maximum likelihood within-host phylogenetic trees for all of the participants. Please note that these trees will only contain unique HIV sequences isolated from each participant. In cases where we isolated the same sequence more than once, only the earliest instance of this sequence was included in the phylogeny. Overall, we isolated a minimum of 11 sequences per each time point. As shown in Figure 1, Participant 1 was diagnosed with HIV in 1996. They initiated CART in 2008, but this was interrupted in 2010, and they had detectable viremia from October 2010 to October 2011. After this, CART was resumed and plasma HIV was suppressed to undetectable levels until the last follow-up. As shown in Figure 2 and as legend on bottom left, a within-host phylogeny was inferred from pre-CART HIV RNA sequences from 16 plasma samples and proviral sequences from 4 PBMC samples. Here, the root of the phylogeny represents the most recent common ancestor of the dataset, or in other words, our estimate of the transmitted founder virus. As you can see, early in infection, HIV diversity is limited, and these viruses are not too divergent from the root. But as time goes on, HIV sequences become increasingly distant from the founder virus, as well as more diverse from one another. This increasing divergence and diversity over time is characteristic of within-host evolution. This evolution can also be seen in the highlighter plot that accompanies the phylogeny. This shows envelope amino acid sequences in the same order as the phylogeny. The top sequence serves as a reference, where colored ticks in sequences beneath it denote the non-synonymous substitutions with respect to the reference, reflecting tremendous envelope sequence variation and increased diversity over time. Now, going back to the phylogeny, I want to draw your attention to the fact that the proviral sequences we sampled on suppressive CART, shown as red diamonds, interspersed throughout the whole phylogeny. For example, we isolated one provirus that clustered with the earliest sample plasma viruses, suggesting that this provirus was seeded shortly after transmission and had persisted since then. Overall, our findings are consistent with proviruses being archived throughout infection and persisting there, such that the proviral pool on CART recapitulates much of the viral diversity that arises during untreated HIV infection. The next figure plots each sequence divergence from the root versus their sampling date. We then use these data to calibrate a linear model that relates the root to tip distances of the pre-CAR plasma HIV RNA sequences to their sampling dates. This linear model is then used to convert the root to tip distances of the proviruses sampled on CART to their estimated integration dates. In Figure 5, we show these estimated integration dates along with the confidence intervals. You can clearly see how these span a wide age range. Though most proviruses date to the chronic phase of infection, with fewer dating to early phase of infection as well. And now here in Figure 6, we show the integration date distributions of sampled proviruses stratified by the date of sampling. On average, sampled proviruses were 8 years old, with the oldest being 16 years of age. Notably, the proviral integration date distributions remained stable over 5 years on CART. Participant 1 also gave us the opportunity to compare the age of HIV sequences emerging following treatment interruption versus those in the overall proviral pool. When we did so, we observed that rebound viruses were significantly younger than the persisting proviral pool. This suggests that these viruses emerged from a recently established replication-competent reservoir as compared to the older persisting proviral pool, which consists largely of defective proviral sequences. Participant 2 was diagnosed with HIV in 2002. They initiated CART in 2008, and viremia remained suppressed until last follow-up. Vaginosis HIV phylogeny was inferred from pre-CART HIV RNA sequences from 9 plasma samples and proviral sequences from 3 PBMC samples. The proviral sequences interspersed throughout the phylogeny, with relatively fewer dating to early infection. Unique proviruses were 5 years old on average, with the oldest being 8 years of age at initial sampling, with most dating to chronic phase. Also, proviral integration dates remained stable over the course. Participant 3 was diagnosed with HIV in 1999 and initiated CART in 2013. Vaginosis phylogeny was inferred from pre-CART HIV RNA sequences from 9 plasma samples and proviral sequences from 1 PBMC sample. The proviral sequences interspersed throughout the phylogeny, with many dating to early infection, and the spread was more even. The unique proviruses were an estimated 7 years old on average, with the oldest being 13 years of age. To summarize, consistent with reports in males and females with HIV subtype C, proviruses sampled on CART spanned a wide age range, with some dating back to transmission. This is consistent with ongoing archiving of diverse proviral lineages pre-CART and their subsequent persistence. In 2 participants, proviruses sampled on CART dated primarily to chronic infection, with relatively few proviruses dating to early infection. In the third, proviral integration dates spanned their pre-CART history more evenly. We did not observe any participants whose proviral pools were dramatically skewed towards integration dates immediately before CART. In the 1 participant who interrupted CART, the viruses that emerged in plasma following this interruption were significantly younger than the total proviral pool. This is consistent with more rapid turnover of the replication-competent reservoir as compared to the total persisting proviral pool, which is largely defective. In the 2 participants with longitudinal proviral sampling of proviruses on CART, the stability of these integration dates is consistent with slow decay of the overall proviral pool during therapy. I would like to thank all the study participants without whom the study would not be possible. I am also grateful for the continuous support of my colleagues at Simon Fraser University, BC Center for Excellence in HIV/AIDS, and the WIS team. I would also like to thank CIHR for funding my doctoral studies at the Simon Fraser University. Thank you.